Hey friends, welcome back. In the previous video, if you've been watching, we connected the TV typewriter to the Mark-8 computer and used it as a display for the computer, and it worked pretty well, but you might have noticed that it has some limitations to it. Firstly, the TV typewriter itself is pretty bulky, so just having to drag the Mark-8 computer and then the TV typewriter box and then the display, just a little bit too much, even though the Mark-8 computer is pretty big already. But that aside, it's still a little bit too much. Additionally, if you type characters in, they only go forward. You can't go backwards. So for example, you cannot use a backspace. Obviously, you can implement some sort of backspace functionality like the Apple I computer did with Robout, but it's not the best approach. Additionally, the cursor only moves one position at a time. So if you want to move, for example, down and to the right, using, for example, keys or something like that, you can't really do it with a TV typewriter. You have to kind of space through it. Because of those limitations to the setup, I thought it would be a good idea to build a video card for the Mark-8 and not have to deal with that bulky setup, even though it's still pretty cool and I would probably still use it, but it's just not that practical if you think about it. So the video card that I'm going to build will actually insert into the Mark-8 computer backplane, and it'll be inside the Mark-8 computer box enclosure. So I don't have to drag anything additional with it whenever I move it around. And it will allow us to overcome all the issues that I just mentioned. And fortunately, I actually don't have to design the video card myself because somebody in the Mark-8 community already did it. And that was actually Len Bayles. And he designed this video card right here. I have the PCB for it. I actually met up with Len Bayles when I went to see John Titus in Utah back in August. And he allowed me to use this video card and design for this video card, this PCB specifically, make it available to anybody else that would be interested in building it for their Mark-8. This video card is actually pretty cool. I mean, if you look at it, it looks almost artistic. So I just want to give him credit, and he actually has a website. If you search for Len Bayles on Google, you'll find his website. I think it's like cronworks.com, if I'm not mistaken. He has quite a bit of information on there as well regarding the Mark-8, the Intel 8008 microprocessor, and some other clock work as well. So be sure to check that out. So this PCB actually requires positive 12 volts, and if you remember, the Mark-8 doesn't have a positive 12 volts power supply. It has a positive 5 volts. So it has a voltage booster here on board that boosts 5 volts to 12 volts. So that's pretty cool. And just some specs about this board here. So Len designed this board to fit into the original PCB layouts. So it has a 3.96 millimeter pitch here for the connector. So it'll fit into the original backplane. So the computer that I showed you in the previous video, it should fit in there. If you've ever built a Mark-8 computer, I know there's another version available. I think it's like Budgetronics or something like that. It's a different connector on that Mark-8, so it won't fit that one. And I actually built that computer in previous videos, and I have it right there behind me over my head. But it will only fit the original layout. It also has a positive 12 volt booster, so from 5 to 12 volt booster. If you remember, the Mark-8 doesn't have a positive 12 volt power supply, so we actually have to boost the voltage to get that positive 12 volts. And the most important thing is that it doesn't actually use a real character generator. Instead, it uses an EEPROM, such as this one right here. Because these character generators can be quite difficult to source, so it's much nicer to just go ahead and buy one of these EEPROMs, and these are pretty readily available. And we'll program the EEPROM to have all the characters that we need. In fact, you can program it with anything you want, pretty much, and it will display the characters the way we program it. Again, we can program the EEPROM with the standard character set that a standard character generator would have, or we can just make our own. That's what's pretty cool about it. And also, it has the composite video out, so we have the connector right here. And that's pretty much it. I'll have a few of these boards available for sale at Callingsha.com if anybody's interested in building one. Let's go ahead and get started. I have all the components that we need for the build right above me here, above the board. Some of it might be off screen a little bit. I also have some IC sockets to the top left, and some of the components are still in their packets from DigiKey. And the reason why I keep them in packets is because it's sometimes hard to read the designation on these components themselves. So I keep them in packets because all the part numbers and values are on the packets. And I have a parts list right here. And by the way, you can find this parts list on the GitHub repo Mark-8 reproduction. I'm going to include a link in the description. And it's going to be under the video card directory if I'm not mistaken. But it will have this parts list, and as you can see here on the right side, the part number, you'll see the part number that can be used for each of these parts, and it's linked to the DigiKey part. So you can use this part if you want to. I don't think I used this specific part, at least not for all of them, since I use some of these components such as these resistors, carbon composition resistors. They are new old stock, but the part numbers that are specified here should work as well. And then you have the quantity for each part and the spec for each part and the part number on the PCB. And the GitHub repo also has the PDF for the parts layout, but fortunately we don't need this parts layout. I mean, we can still reference it, but the actual layout, the silk screen is on the PCB, so you can see where each part goes here. Pretty straightforward. Additionally, the GitHub repo contains the schematics for the video card, and it's split up into pieces, so it's a little bit easier to follow. You can reference the schematic if you have issues or if you just want to see how it works. But this will be in the GitHub repo as a PDF. Again, this was designed by Len Bayles, and here it says July 11, 2015, so about 10 years ago. Len also gave me a list of bug fixes that need to be implemented on the PCB, and I made a little document here to make it a little bit easier to follow. But for example, for U19, pin 1, the trace needs to be cut, and pin 1 needs to be connected to ground instead. And there's a U22 bug fix, but we'll reference this a little bit later. Additionally, Len gave me a piece of source code that demonstrates the functionality of the video card. And again, we can see that this was written by Len Bayles in 2015. And one thing about this video card is that it needs 3 output ports, and these output ports are actually hardwired in the board, if I'm not mistaken, and I don't think they can be changed, at least not easily. But basically, one output port is for the column position, the next one is for the row position, and the third one is for the actual character. So as you can see here on the main program, we load 0, 0 into the A register, and then we output it to the column output port, which says the column location, and 0, 0 is also being outputted to the row output port, which says the row. So 0, 0 will be top left, if I'm not mistaken, and then we set some value 48 hex into 8 register, and then we output it to the actual character output port to specify which character to write in that location. And again, we can specify pretty much any position on the screen and then write that character in that position. So there's some flexibility there. So we're not going to need this since the silk screen is already on the PCB. I will reference the part list here just to know which part goes where. And I think we can get started. Actually, one thing I forgot to mention is this character generator, actually the EEPROM, Len gave me a hex file with basically a program to program this EEPROM with. It basically gives us all the dots for each row and column on how to draw each character. So that hex file will be on the GitHub repo as well, and it can be programmed pretty easily. I use something like this, which I got on Amazon. I'm going to include a link in the description if anybody's interested. You insert the EEPROM in here like this, plug it into the computer, and there's a piece of software that comes with this programmer, and you can load the hex file into it and program the EEPROM. And it can actually program quite a few different EEPROMs, so this is pretty useful. Again, this was probably like $50 if I'm not mistaken. It might be also useful to have a, I think it's called a UV EEPROM eraser. It's like a little box or container where you can put the EEPROM into and turn it on, and the UV light will erase the EEPROM. So just in case, be good to have. Okay, let's go ahead and get started. And as usual, we're going to start with the resistors. There are multiple designations for R101, so 1, 2, 3, 4 of them are R101, and they are all 1 kilo ohm, just FYI. You may have noticed that I didn't install the variable resistors, which go somewhere over here. And the reason why is because of their height. They're going to get in the way when we install the other components, such as the IC sockets, so we're going to hold off on that. Yeah, so speaking of IC sockets, let's go ahead and install them. As usual, it's probably a good idea to start with the largest sockets first, just so we don't accidentally install a small socket in a large footprint. And also want to make sure we orient it correctly. So pin 1, where this notch is, will be oriented with the notch on the PCB. All right, got all the IC sockets installed and verified to be correct and not bridging anything. I guess we can continue with the other components. I'm going to go ahead and install the crystal oscillator, and it goes right here. Again, just be very careful when soldering this crystal oscillator because it can easily bridge into the ground plane here. I'm going to go ahead and install the capacitors. So we have a 100 microfarads capacitor right here, and I'm going to make sure that it's oriented correctly. Minus to minus, plus to plus. And I'll install this one and all the other electrolytic capacitors. Next, I'm going to install these variable resistors, and I'm going to hold off on the ceramic capacitors here until later. I'm going to install the lower profile components first, and they go into C4 and R4 and R6. And I guess we can orient it, I guess in any way, but I'm going to orient it with this knob facing bottom left. And as you can see here, there's sort of, the footprint is sort of like a triangle, but these resistors are not, so we're gonna have to bend the middle pin a little bit to make it fit. We also have this variable capacitor, and it goes into C2. I found this on DigiKey. I think I included the part number in the GitHub, and it should fit right into the footprint. So it looks like this capacitor will be used to tune the crystal oscillator slightly. We have this connector here. We have this voltage booster and also the inductor. So next I'm going to install the inductor, but as I mentioned earlier, I need an axial inductor, and the reason why we want an axial is because this there's not much clearance here for a radial one like this, and so yeah, this one won't fit, but I'm gonna have to improvise to get it to work. But first I'm gonna install this voltage booster just so we make sure that we get this installed, and then we can work with the inductor to fit it in there. Okay. Yeah, and as you can see, there's like pretty much no room for the inductor. So we got these longer leads. Now we can insert it into the footprint. Okay, I think that's a pretty good temporary solution. That will work. Next thing I want to do is install these bottom connectors, and we have these are Molex connectors. We have 3 10 position connectors and 1 11 position connector. These are the same ones that we use for the other Mark-8 boards as well. So, and the reason why we have 310 and 111 is because there are 41 positions on this bottom connector for the Mark-8 backplane, and there are no 41 position Molex connectors on the market, so we have to improvise. Okay, we have a couple of components left. We have some transistors right there. I think let's go ahead and install those. And these are the same ones, so it doesn't matter which one we install where. And we can orient it with the way that it's oriented on the footprint. And then we can install this composite video output. Alright, so the only thing that's left other than installing the IC sockets are these capacitors here. And we have a couple of different capacitors. We have quite a bit of these 0.1 microfarads, which we'll install a little bit later. But let's go ahead and just install all of them by following the layout sheet and the parts list. Okay, look at that. It looks beautiful. Looks pretty good. I guess what I'm going to do next is I'm going to wash it underneath, let it dry, and then I'm going to insert all the ICs, and then we can plug it into the Mark-8 computer and give it a shot. So let me go ahead and wash it first. I just programmed the EEPROM with the character generator Intel hex file. So I'm going to remove it from the programmer and go ahead and insert it into the board. Might be a good idea to also cover this up just to protect it from any UV light, but I'll probably do that later. Actually, there's one more thing that I forgot to do, and that is to fix these bugs reported by Len. I took a look at U19 pin 1 and it said to cut the trace and then connect it to ground. And U19 pin 1 already has a pin 1, so yeah, the pin 1 is already connected to ground. So I think that mistake has been fixed in this PCB. U22, it says cut trace between U22 pin 9, which is this right here, and CA. The CA is right beside it here. And then it says to run the jumper from CA to hole 3 of U22, so right here. And actually, I believe these connections here are to select the output ports. So when I said it was hardwired, I guess it is sort of hardwired, but it's still configurable. So yeah, let me go ahead and run a little jumper wire from CA to 3. I already went ahead and cut the trace. Let me show you right here. So I cut the trace between CA and pin 9 of this IC. And I'm going to go ahead and install a little jumper wire here. Okay. So we got CA connected to 3, and I think this board is ready to be inserted into the Mark-8. And for the video card to work, we actually need to modify the backplane slightly. So as you can see here, I actually connected the 8 bits of data that were originally caught on the backplane before the input board and the CPU board. And that way I can actually insert the video card and any other card that I might install in the future. Basically where the input board and the CPU board were sitting originally. And I moved the input board and CPU board to the back of the computer just so that all the caught data lines only affect those 2 boards, as you can see here in the video. So I just played around with the video card and had some issues with it. I wrote a little program to reset the screen to all blanks, and it wasn't working properly. Basically, the column position wasn't changing. And there's one thing that I just realized while I was debugging it, and that is the fact that if you remember, we made some changes here. We cut a trace on this side, actually, right here, between the CA position and pin, I think pin 9 of, I think that's U32. We cut the trace and we connected CA to pin or position number 3 here on this side, right here. And that's actually incorrect. It actually has to be connected to position 6 here, and that's actually what CA was already connected to. So I think the bug list that Len gave me may actually be out of date, and he already updated the PCB to be correct. So I went ahead and redid the jumper wires, actually the single jumper wire that we had here, and connected CA to pin or position number 6, and it fixed the issue that I was having. And by the way, these positions here, the CA, the RA, and the DI, I believe they stand for column address, row address, and data in, probably data in address or something like that. That'd be my guess. But yeah, I went ahead and wrote a little program to reset the screen, and I just entered it in, and I haven't executed it, so let's go ahead and see if it works. So I'm going to go ahead and toggle or run the program. Yep, and it doesn't work. I think I have a mistake. Let me see if I can fix it. Well, I think I found the problem, and that 174.123 that the cursor increment signal is coming out of is actually has one of the pins not soldered in. I think that's the ground pin, if I'm not mistaken. So yeah, be sure to check all the solder joints, make sure they're soldered in and also properly soldered in. Let me go ahead and solder it in, and we'll give it another try. Okay, let's try it again. I'm gonna toggle the interrupt switch. Awesome. So it looks like we got the screen cleared. There are some issues here that I'm seeing. So first of all, there's two cursors. And actually I think Len said that it might be because of the screen positioning. I'm not sure about that yet. Also, we're seeing something here which wasn't cleared. I think what that means is that we need to clear 2 more positions here. So I need to modify the program to do 2 more iterations for writing a space for 2 more positions, and that should fix that. Also, we're seeing something here, and I think it's related to the screen positioning, but I haven't dug into that yet. But yeah, I think that's pretty good, and I can rerun it, and we can kind of see the cursor jumping around while it clears it. Went ahead and modified the program, and now it clears all the positions. Looking pretty good. I just entered another program into the Mark-8, and this program is supposed to read input from our keyboard here that goes into the computer and output the data onto the screen through the video card. So as you can see, I already tried it out, but let me reset the program. And as you can see, it didn't clear the screen for us, which is one of the functionalities that we can implement still, but it did reset the cursor back to the top. So let's say we want to type in hello. And by the way, I don't know if you noticed that, but the top most row here is being cut off. I can't see it for some reason. I still have to investigate what's going on here. I just can't see the dots for the top row of each character at the top of the screen. But there I tried to type in hello, but as you can see, it gave us some wrong data. So we can actually go on our keyboard and type in, press the rub out key, and it takes us back 1 spot, and then we can type another L in its spot, and we can go to the next line, and we can type in whatever you want. And this program is actually pretty long, and it's a little bit time consuming to enter it in. And that's actually one thing that I want to resolve in the next video of the Mark-8 series, on how to actually load programs much quicker instead of having to toggle it into the Mark-8 using the toggle switches. Well, I guess the one thing that's left for me to do is resolve this problem here, where the last, or I guess the topmost row is not being displayed. I'm not sure why it's doing that. And also this issue here is like a couple of dots here on the bottom. Not sure why it's showing them. It might be the screen. That's the issue. And also, if you remember, the cursor was also shown up twice. If we go all the way to the top of the screen, yeah, there you go. So we can see the cursor twice, as if it's displaying. It's basically copying the cursor multiple times. So I don't know if it's an issue with the screen or maybe the video card. Still gotta investigate. But so far I'm pretty happy with it. I think Len Bayles did an amazing job designing this video card, and it's actually pretty well designed, so pretty happy with it. I went ahead and hooked up the video card to a composite video to HDMI converter and hooked it up to my computer, and the video looks pretty good. It's crisp, it's clean, the boundaries are correct. We're not seeing the random dots on the bottom of the screen, and we're also seeing a single cursor, so that's good. But the missing dots at the top of the screen, we still have that issue, so I'm not exactly sure what's going on there. I'm going to spend some time trying to debug it, but if anybody has any ideas on what the issue might be, please do let me know in the comments, and I think that's going to help me a lot. Well, I hope you've enjoyed watching this video, and please don't forget to click the like button and subscribe if you haven't already, and I'll see you in the next video.